Understanding of the universe and our place in it has been drastically altered by the discovery of the Andromeda Galaxy. Our Milky Way galaxy is one example. The Andromeda Galaxy is the next closest, and we estimate that over 100 billion galaxies are visible in the universe. As such, it provided conclusive proof that Earth is not the center of the universe or the universe itself. We are but a small speck in the vastness of the cosmos, as this revelation disproved the theory that the Milky Way was the only galaxy. Much of what we know about Andromeda was learned from Earth-based observations during the past century. But now that we have sophisticated instruments like the James Webb Space Telescope, our view is completely different. Recent data from the James Webb Telescope has completely flipped our perceptions of the Andromeda Galaxy on its heads. When the jwst picked up signals from the nearby galaxy, the scientific community was taken aback. This is just one of many cosmic mysteries that still need to be answered. Welcome space enthusiasts to Cosmic Signals, Unveiled, the channel where we explore the mysteries of the universe one signal at a time. Join us as we decode this cosmic message, uncover its hidden meanings, and take you on a voyage to the very edge of the cosmos. Andromeda, our neighboring galaxy, sent a distress signal that we'll be investigating. Indeed, the vision of the Milky Way has experienced major modifications over the course of human history, inspired by our developing understanding of the cosmos. In the past, when human technology was less advanced, the Milky Way looked as a diffuse band of light over the night sky, leading to different mythologies and explanations. In the cosmological beliefs of many societies, it played a significant and magical role. The advancement of science, especially the invention of telescopes and the efforts of astronomers like Galileo Galilei, led to the realization that the Milky Way was not merely a nebulous idea in the sky, but rather a massive assemblage of stars, planets, and other heavenly bodies. Our perception of the world around us has been changed by this discovery. We now know for sure that our Milky Way galaxy is a barred spiral galaxy containing billions of stars, including our own sun, due to modern telescopes and astronomical studies. As our knowledge of the cosmos expands, so does our admiration for its marvelous intricacy and beauty. With the 100-inch Hooker telescope at Mount Wilson Observatory, American astronomer Edwin Hubble made a revolutionary discovery in the 1920s. Hubble saw nebulae beyond our Milky Way galaxy. He demonstrated that these objects were not a part of the Milky Way by seeing and analyzing them, but in actuality were totally distinct galaxies, each containing billions of stars. The Andromeda Galaxy is one of these galaxies that is rather close by. The Andromeda Galaxy, or M31 as it is sometimes referred as, has been observed extensively for millennia. In star charts from the 10th century, Persian astronomer Abdul al-Rahman al-Sufi characterized this celestial phenomenon as a tiny cloud, making it one of the earliest known accounts of this item. Its nickname, the Little Cloud, may stem from the fact that when viewed from Earth, it appears to be surrounded by a thin cloud. This identification by al-Sufi, who relied only on his keen eyesight and observations, is significant since it shows that he was able to locate this distant cosmic object without the aid of telescopic instruments. That's possible because Andromeda is one of the few galaxies in the universe that can be seen from Earth without any special tools. You can find it in the clear sky if you know where to look. Even though you couldn't make out much, you can see that it's not just the regular old stars. To explain why a more comprehensive depiction of the Andromeda Galaxy based on telescopic observations wasn't offered until 1612, we need to look back to Simon Marius. As time went, astronomers would build upon his work to learn more about this cosmic phenomenon. Later in 1764, the famous French astronomer Charles Messier included the Andromeda Galaxy as M31 in his renowned Messier catalogue, incorrectly crediting its discovery to Simon Marius. It doesn't imply, though, that he didn't play a significant role in establishing Andromeda's prominence, if only by naming it. Later, for almost 100 years, scientists from all over the world kept trying to figure out more about this strange galaxy, with each new discovery building on the last. Earlier in the early 17th century, it was Italian astronomer Galileo Galilei who radically altered our perception of the Milky Way. The observations he made with his brand new telescope shook up the accepted Aristotelian view of the universe. As he looked deeper into the sky, he saw that the Milky Way was composed of countless stars, planets, and other astronomical bodies, rather than a single diffuse light strip. He used his findings to prove that the Milky Way is just one of many star systems in the universe, and not the center of everything. Thomas Wright, an English astronomer, put out a novel theory or hypothesis of the cosmos in 1750. Wright hypothesized that the Milky Way was actually a perfectly flat blanket of stars rather than a random distribution throughout space. He went on to imply that our solar system was but a little part of this enormous complex. Wright's proposal advanced our knowledge of the Milky Way structure, but it was still constrained by the limitations of the available observational equipment at the time. Not surprisingly, given the constraints, everyone still thought the Milky Way was the boundary of the cosmos. In 1864, English astronomer William Huygens produced a groundbreaking observation that greatly advanced our understanding of the Andromeda Galaxy. He looked at the Andromeda Galaxy's spectrum and saw that it was distinct from the spectra of regular gaseous nebulae. It paved the path for the world to actually get to know Andromeda for what it really is. It's a lot, but the Andromeda Galaxy's mass is just around 1 trillion times that of the Sun at most. It's a huge cosmic structure that exists in close proximity to our solar system. Based on the data gathered so far, astronomers estimate that Andromeda is somewhere around 10 billion years old. Its antiquity suggests a protracted and complex process of origin and development. The theory that Andromeda formed from the merger of multiple smaller protogalaxies is an intriguing part of the galaxy's genesis. This indicates that the magnificent Andromeda Galaxy we see today was formed by the gradual merging of smaller galactic entities under the influence of gravity over a period of billions of years. Such galactic mergers shape the development and structure of galaxies, and they occur often throughout the universe. However, because of how slowly things progress, you may not notice any changes until it's too late. The idea that Andromeda is more enormous than our own Milky Way galaxy has been around for a long time. Seeing Andromeda from Earth makes everything look so huge that you would easily think that there is nothing that could even come close to its magnitude, but from an objective point of view, we are in our own galaxy, so this mistake is understandable. This, however, is not the case. Massive galaxies are a result of the interplay between the star gas dust and dark matter distributions and motions inside the galaxy. Pinpointing these values accurately is a tough task that involves advanced observing techniques and rigorous analysis, therefore it couldn't have conceivably been done in the 1700s or even in the 1800s. The fact that the truth is just now being revealed is a result of the sophistication of the methods used to uncover it. These ideas have been re-examined in light of recent studies. Scientists have revised their estimates, decreasing the mass they had allocated to Andromeda while boosting the mass they gave to our Milky Way. That's why scientists now believe that the two cosmic giants' masses are closer together than they once imagined. From Andromeda, you would see an equally huge galaxy if you gazed onto Earth. To put the Milky Way's size in perspective, consider this. But what astronomers agree on is the Andromeda Galaxy's physical size. With a diameter of around 220,000 light-years, it dwarfs even our own Milky Way in size. Andromeda's diameter is larger than the Milky Way's by a factor of about 100,000 to 170,000 light-years. The enormous size of Andromeda makes it a cosmic entity in its own right, encompassing a vast region in space. This new viewpoint also emphasizes the difficulties and complications of precise galaxy mass measurements. As the center of the Andromeda Galaxy, the supermassive black hole there has a tremendous effect on the stars in its vicinity. These stars, as they orbit the black hole, travel along elliptical orbits, much like the planets in our solar system. Black hole elliptical orbits are called perihelion and aphelion. Stars travel at their utmost velocities because gravitational forces are strongest at the perihelion. Stars cluster and become more densely packed in the region around the black hole when this happens. As the stars cluster together, they emit energy in the form of radiation. This includes both visible light and other forms of electromagnetic radiation. The higher concentration of stars and the discharge of radiation form the brighter point of concentration that astronomers witness in the galactic core of Andromeda's AGN. There will be further discussion about this at a later time. Knowledge of the gravitational dynamics and star-black hole interactions is greatly aided by this unique property. The definition of an AGN will help us grasp this concept. The energetic center of a galaxy is called the active galactic nucleus, AGN. The source emits strongly in a wide range of frequencies, from radio to X-rays. Powering AGNs is a supermassive black hole located in the galaxy's core. A supermassive black hole is a region of space where an extremely high concentration of mass occurs in a relatively compact area. The active galactic nucleus is home to a fascinating phenomenon that may be observed by advanced observatories like the Hubble Space Telescope. One of the most remarkable properties of the Andromeda Galaxy is its AGN. It looks to have two foci or centers from which light and other radiation are coming out at higher levels than in the surrounding space. The brighter concentration is the secondary focus, which is just slightly offset from the actual core of the galaxy. The black hole is located in this region. According to estimates, this black hole weighs between 110 million and 230 million times as much as our Sun, or 1.1 to 2.3 times 10 to the power of 8 solar masses. It is widely thought that supermassive black holes can be found at the galactic centers of most galaxies, including our own Milky Way. Therefore, they are extremely important to galaxy dynamics and evolution. An accretion disk is created when gas and stars fall into a supermassive black hole. The AGN's brightness is due to the intense radiation emitted by a hot whirling disk of material. A stronger concentration can be seen by astronomers around the center supermassive black hole in the Andromeda Galaxy's active galactic nucleus. The black hole's peculiar gravitational interactions with the nearby stars are responsible for this peculiarity. Another remarkable quality of the Andromeda Galaxy is the sheer number of globular clusters it contains. These globular clusters are tight groups of stars that orbit around the center of the galaxy, kind of like satellites revolving around a planet. It is thought that Andromeda is home to 460 of these clumps of stars, each of which contains hundreds of thousands to millions of stars that originated at roughly the same period. Insights concerning Andromeda's cosmic history and interactions with smaller galaxies over billions of years can be gleaned from its extraordinarily high globular cluster count. This evidence points to Andromeda's role as a galactic cannibal actively consuming its smaller neighbors. The tremendous forces of Andromeda's gravity strip smaller galaxies of their stars and other components as they approach. Part of the Paradise Paradox is the fact that the past is reflected in the future, with the vast diversity of the past reflected in the great diversity of the present. This property of gathering globular clusters and stars from smaller galaxies is considered typical for spiral galaxies like Andromeda. Spiral galaxies, which are disc-shaped with prominent spiral arms, provide fertile ground for encounters and mergers with their smaller companion galaxies. Recent observations and analysis have led some astronomers to speculate that the Andromeda Galaxy is undergoing an intriguing change in addition to its other unique qualities. This galaxy looks like it's changing from the more common spiral shape to the more unusual ring shape. The circular or elliptical ring structures of ring galaxies are fascinating and unusual features of these astronomical phenomena. There are many hot youthful blue stars in the rings, but not as many in the core region. Ring galaxies are easily distinguished from the rest of the galaxy due to their distinctive characteristics. In the area of normal galaxy morphology, there are three primary types of observed optical ring phenomena: nuclear rings, inner rings, and outer rings. Inner and outer rings of a galaxy are positioned at greater distances from the galaxy's nucleus than are nuclear rings. There are two main classes of ring galaxies, the O-type and the P-type, but the story doesn't finish there. O-type ring galaxies have smooth, regularly shaped rings, and their nucleus are located at the center of the galaxy. P-type ring galaxies, on the other hand, have nuclei that aren't at the center and have rings that are more asymmetrical. About 1 in every 10,000 galaxies is a ring galaxy, making them a rare cosmic treasure. Observers have proposed two primary explanations for how ring galaxies originate. A primary mechanism for their formation involves the impact of two or more galaxies. A smaller galaxy can also cause a ring-like structure to form when it passes through the center of a larger galaxy. Some ring galaxies, like the Cartwheel Galaxy AM 2026-424 and ARP 147, are likely to have formed as a result of galactic mergers. Therefore, this is not a straightforward galaxy, but rather one with many moving parts. But the current events are far more fascinating. A new supergalaxy will be formed when the Milky Way and the Andromeda Galaxy collide, according to scientists. Names like Melcometer and Milkdromeda have even been coined to describe this enormous phenomenon, which is now well known on a global scale. These names may seem lighthearted and humorous, but the effects of this merging on humanity would be catastrophic. New stellar nurseries can be created as gas clouds meet and compress during the merger process. Young huge stars suited to the new galaxy are born in these nurseries. The sky is a cosmic light show as galaxies collide. As a result of the impact and subsequent merger, spectacular star clusters, shock waves, and dazzling bursts of radiation will be produced. As new constellations and star configurations form, the night sky changes. The entire sky will be replaced with something completely new. However, while these events will be massive in scope, their impact will be far-reaching. Huge cosmic forces and interactions between stars' gas and dust will cause dramatic shifts in Earth's environment as the Andromeda Galaxy and the Milky Way collide. Depending on the specifics of the change, it may disturb existing habitats, modify existing biodiversity, or even cause local extinctions in the biosphere. When these two galaxies finally collide, the enormous gravitational forces between them will change the forms of both. As a result, tidal interactions occur in which stars' gas and dust are dragged along with the galaxies. There will be widespread damage as the galaxies collide. But it won't occur overnight. The merging process begins as the galaxies continue to approach one another and collide. There is a lot of star and gas and dust cloud mixing between the two galaxies. When galaxies merge, new star clusters and structures can arise within the galaxy. Stars' orbits undergo dramatic shifts during the merger, creating a dynamic and chaotic environment in the merged galaxy. It's possible that some stars will be thrown out of the new galaxy, while others will settle into more elliptical orbits. Both galaxies are home to enormous black holes. These black holes will eventually merge during the collision, creating a single, much larger black hole at the center of the united galaxy. It's possible that Earth's climate and weather would be affected by the merging of galaxies, since it would cause disturbances in the solar system. Possible global shifts in temperature, precipitation, and weather events could alter plant and animal distributions. Potential ecosystem disruptions may result from changes in solar radiation's impact on vital processes for plant and animal existence. As a result, they may be in danger much sooner in the process of amalgamation. Also, the ozone layer and other atmospheric components of Earth could be affected by an increase in cosmic radiation from the intergalactic region. This may cause a shift in climate, which could have long-term consequences for the well-being of many species. The changing air composition may have an effect on photosynthesis and other life-sustaining activities. In the wake of the environmental shift, certain species may flourish, while others may struggle to make it. Increased competition for resources is possible, and new possibilities for particular species to thrive in the changed ecosystems are possible as well. Not all animal species will be able to adjust to the new environment, which could cause local extinctions. There may be a domino effect on the entire ecosystem if particular species disappear from certain location or habitats due to changes in habitat or migration patterns. This is concerning since many animal species rely on predictable migration routes to ensure their survival. Disruptions in habitats and a changing climate may cause these migration routes and timings to be disrupted, making it more difficult to locate food, water, and good breeding grounds. Changes in climate and habitats may have an effect on the range of organisms found within an ecosystem or biodiversity. While all of this is heartbreaking, the reality is that even if the galaxies are on a collision course, the process won't actually happen overnight. The collision is expected to begin approximately 4 billion years from now, and the entire merging process will take another 2 billion years to complete. As for our species, we will be long gone by then, and our planet Earth will have undergone tremendous changes long before the collision even begins. Around 5 billion years from now, our Sun is projected to evolve into a red giant, eventually expanding and engulfing the inner planets, including Earth. This process will likely render our solar system uninhabitable long before the merger between the two galaxies takes place. Whether this results in Milky becoming an elliptical galaxy or a large disk galaxy is something we won't find out until the merger actually happens. But the way things are, it's possible for the merger to go either way. As the Andromeda Galaxy and the Milky Way merge, the cosmic forces and interactions between stars' gas and dust will shape a new galactic structure different from what we've always known. Within this merged galaxy, there may be star systems with planets orbiting in the habitable zone, where conditions could be suitable for liquid water to exist. It's widely agreed that liquid water is essential to the emergence and survival of life as we know it. However, the viability of life will depend critically on how well the new galactic structure holds together. 4 to 6 billion years from now, if any descendants of our species or other living forms exist, they will be quite remote from us in evolutionary history, being nothing like us today. Our solar system's future within the new supergalaxy remains uncertain after the merger. Our solar system may be flung into the void of space itself during the impact. There is no way to know for sure what will happen or how the new galaxy will be structured. One possible result is the separation of each galaxy's spiral arms and the disruption of their respective galactic disks. There could be planetary systems in this merging galaxy that have planets in the habitable zone where liquid water could exist. Planetary orbits and climatic circumstances may be influenced by the interaction between stars and potential gravitational disturbances, which in turn may affect the evolution and sustainability of life on any potentially habitable planets. Although rare events like supernovae and gamma-ray bursts can be triggered by galaxy mergers, the actual occurrence of these events and their impact on planetary environments is hard to predict. It's conceivable that any new life that forms in this galaxy will have to adjust to the harsh realities of its surroundings. A new kind of life unrelated to Earth's may emerge as a result of the new galactic region's specific physical and chemical features. Current human beings, however, have no chance in the emerging cosmos. As we wrap up our journey today, a big thank you for joining us at Spaceverse. Your support fuels our cosmic exploration. Don't forget to subscribe and hit the notification bell to keep exploring with us. Until our next cosmic encounter, see you.